Welcome to the Women in STEM Symposium of 2023. My name is Aditi Singh, and I am a senior in the college pursuing a master's in bioethics and majoring in neuroscience. I'm a crew chief EMT at the Penn's Medical Emergency Response Team and also the lead math tutor for Weingarten. It is my privilege to introduce Dr. Jane Hollonen, Executive Director of the Weingarten Center, which provides academic support and disability services for Penn students across all 12 schools at Penn.
Thank you, Aditi, for that lovely introduction. I'm delighted to be here with you today, the annual Women in STEM Symposium of 2023. The symposium is a long-standing collaboration between the Office of Affirmative Action and the Weingarten Center, with increasing contributions from campus partners. Each year, the symposium has explored different facets of women's participation, presence, and proficiency within the STEM disciplines and careers. With great pride this year, we are celebrating students' experiences of pursuing STEM degrees and disciplines. It is my deep privilege to introduce Dr. Antonia Villarruel, professor, and Margaret Bond Simon Dean of Penn Nursing, the #1 school of nursing. Dr. Villarruel, please.
Great. Thank you, Jane. How wonderful to be here with you and to provide some opening remarks. What a fabulous event. And again, just an opportunity to raise up and to support and amplify the journeys you all have chosen to pursue in the STEM field. As Dean of the Penn Nursing School, it's encouraging to choose STEM careers, as you might imagine, very personal to me. But it's interesting to note that there is a debate as to whether nursing, in fact, is a STEM discipline. It depends on the definition and who you talk to. The definition of STEM field by the National Science Foundation, for instance, is all fields of fundamental science and engineering. Many would say that nursing is an applied field, not focused on fundamentals of physical science, and so there's no STEM designation. If this is true for nursing, what about pharmacy? What about medicine? Some say biology is really just applied chemistry, which is really just applied physics. However, Florida does include STEM as a field because it includes a number of hard sciences. And I'm telling you, I took my share of hard sciences, including anatomy and physiology, biology 1 and 2, chemistry, microbiology, and I want to tell you, I passed out of physics, so I didn't have to take that at the graduate level. But it includes the acquisition and application of science-related content. So let me give you a few examples of the contributions of nurse scientists, some of who were Penn grads, and you tell me whether you think they belong in a STEM discipline, whether nursing is a STEM discipline. So first is Dr. Polly Joseph. She is a native of Venezuela, a family nurse practitioner, a Penn PhD grad, who is a research scholar at the National Institutes for Health. She has her own lab, and her group are conducting preclinical, clinical, and translational studies that aim to improve the diagnosis, prevention, and management of chemosensory disorders and symptoms. Now, she was doing this before COVID. Dr. Joseph's laboratory is leading research that is aimed at enhancing the understanding of molecular, cellular, neural, and behavioral mechanisms underlying symptoms to identify new targets for treatment and improve symptom management strategies. As a nurse and a family nurse practitioner, Dr. Joseph has worked extensively with individuals with diabetes and obesity, individuals undergoing weight loss surgery, and alcohol and substance use disorders. She brings a unique and necessary perspective to the study of taste and smell alterations by incorporating both clinical and bench science approaches to unite 3 fields of science: nursing, sensory biology, and omics. Dr. Wendy Henderson is a pediatric nurse practitioner and was a tenured faculty also at NIH. As a primary investigator on multiple studies at the NIH, she is currently focused on looking at the brain, gut, liver microbiota axis and chronic effects of stress on intestinal health across the lifespan. As a practitioner, she developed the gastrointestinal pain pointer technology to provide clinicians with a more integrated tool for GI symptom assessment, one that includes location, intensity, quality, and physiological parameters. Through a brain-gut natural history study, Dr. Henderson also assesses brain-gut-liver interactions in normal weight and overweight patients with chronic abdominal pain of unknown origin. Both of these individuals, again, both the applied and also basic sciences, they bring to their practice and also their research. And finally, Dr. Patty Brennan is a Penn Nursing grad and also happens to be an industrial engineer. She is the director of the National Library of Medicine. While she's not a librarian, she is a leader in biomedical informatics and computational health data science, and she is in charge of that for the entire NIH. She has championed the discovery of new analytic and data science advances. Wow. So why the exclusion of nursing, and why does it matter? Could it be, by chance, sexism because nursing is a woman-dominated field? But regardless of whether you consider nursing a STEM profession or not, there is a common denominator: how to encourage and support women to take up math, science, and engineering at whatever point in their career. How do we turn the perception that women don't belong in many of these fields? How do we transform this from a barrier to an opportunity? Certainly, the number of high school students in math and science are just about equal, but the proportion of women steadily drops as you move up. And it's not because women aren't interested or that they don't have the capabilities. Fewer women at high levels in science means fewer people think of scientists as women, or as a traditionally female-dominated field such as nursing, as science-related. But despite this miscalculation, women are making gains in STEM careers. According to the National Science Board, women make up about 34% of STEM workers, representing 44% of those with a bachelor's degree or higher, and 26% of those without a bachelor's degree. Data from 2019 tells us that the highest percentage of women is in the biological sciences at 48%, and lowest among engineers and architects, about 60%. Data from the Pew Report reveals that fewer than a quarter of computer or engineering jobs are comprised of women, while 74% of women are in health-related fields. Again, definitions matter. For context, around that number, women making up 34% of the STEM workforce in 2019, while in 1970 only made up 8% of the workforce. So certainly the number of women in the STEM workforce is expected to keep growing because the number of women getting degrees in STEM fields is increasing. Data from the Integrated Post-Secondary Education Data System tells us that 45% of the college students who majored in STEM fields in 2020 were women. And this is a 10% increase since 1994. That is clearly news to be celebrated, and we still have a lot more work to do. Diversifying the STEM workforce is much more than just attracting women to STEM careers. Women of color continue to be significantly underrepresented in STEM. A Pew Research Center study from a few years ago found that in the STEM workforce overall, 9% of workers are Black, 8% are Hispanic, and 13% are Asian. Interestingly enough, healthcare professionals, including health nurses, dental hygienists, vets, are included in this designation. But adding to this disparity is the continued gender and racial ethnic minority gap in salaries. Highest on the pay scale are Asian women, are Asians at $103K, followed by white men, and it's lowest for Black and Hispanic women, around $57K. And that is similar to what is found in non-STEM fields. So what do we do about this gap? Well, it starts with you. It means that we want you to reach the success in STEM education and the profession that you have chosen, that you have outlined for yourself. The journey can be challenging, but there are plenty of people around, your peers, your professors, I should say the Weingarten Center, and others throughout the university to support you. We want and need for you to be the role models that you are. One of my inspirations, although she's not in a STEM field, supports women in STEM, is a Penn Wharton grad, Caitlin Grasso. She was an inaugural winner of the President's Engagement Prize and used her $150,000 prize to accelerate a nonprofit she formed called Generation, a network where young women and companies connect. It was an effort to fill the gender gap in business, and through a series of camps, webinars, and small meetings, Caitlin worked with tech giants, sports franchises, and government agencies, including NASA, to introduce possibilities to girls and young women. Another important component you can do individually and collectively is to lift up and support your female peers, professors, and administrators. And I will include deans. Deans needs lifting up too. Diversification means more than numbers. It means fostering belonging and support. And we each have a role to play, whether it's inviting someone to a study group or affirming an opinion or viewpoint that might not be popular. The symposium today, I am hoping, inspires that spirit of belonging among you, our most precious resources, our students. Importantly, I want you to know that as part of the university community, I am here to help, support, and amplify your work. This is how we help women and each other grow and succeed in STEM careers and beyond. As I said, we all have a part to play. Thank you again for letting me share my thoughts with you today, and thank you for participating in the Penn Women in STEM Symposium. The future that we fight here for today is important for all of us. Best of luck with the rest of the symposium.
Thank you, Dean Villarruel, for creating a remarkable opening to the Women in STEM Symposium. I'm Harper Green, and I am a sophomore in the college studying computational biology. I will also be the moderator for today's event. As a reminder, throughout our program, we encourage you to take advantage of closed caption found in the menu below your video screen. A recording of the full symposium will be available to you in about a week. The symposium will now continue with a student-led assembly focused on lived experiences, followed by remarks from Dr. Erika James, Dean of the Wharton School. Remarks by Dean James will be followed by two assemblies, the first on research and the next on career progression. The first assembly on lived experiences will be presented by Nebiat Geber-Georgis, Sarah Kane, Olivia Schuler, and Ishvathi Raghavakaimal. This panel explores the heterogeneous experiences of female STEM students. Discussion focuses on learning what women have endured, accepted, and valued within their individual STEM journeys. Throughout the panel, we invite you to use your reaction buttons and the chat to share reactions and comments. Please share questions for our panelists using the Q&A feature in your menu below the video panel. At this time, I'd like to welcome our panelists, please. Hi, everyone. I am going to ask you to please introduce yourselves and then to answer this first question. As a woman in STEM, how do you take up space in the classroom, lab, or anything else? Have you ever experienced not being seen in STEM spaces? And what are the ways we can be seen in these spaces? Nebiat, I'm going to ask you to answer first, please.
Sure. Thank you very much for the opportunity. My name is Nebiat Geber-Georgis. I'm a third-year undergraduate student studying biology with a minor in psychology, chemistry, and healthcare management. I'm also an undergraduate researcher at Dr. Brown Lab in the Abraham Cancer Research Center. Going back to your question, I think taking up space in classroom labs, etc., is really important, as oftentimes women tend to be overlooked and not taken seriously in these spaces. And I've definitely found myself in situations where I was not seen or heard. And I think there are some strategies that have helped me thrive in those situations. One of them, which is speaking up, like I'm not being afraid to share my thoughts, ideas, and opinions, is really important, because regardless of what other people might think in those settings, our perspective inputs are variable and offer a very unique perspective into whatever is being discussed. So speaking up helps us establish ourselves as a capable and active, engaged member within that community and setting. Besides that, I think volunteering to take leadership roles, initiations to perform certain tasks is also an important aspect. Sometimes there might be a situation where there are opportunities to take or tasks to be done, and some people might just be hesitant to assign those to the women in the field, in the team. So I think it's really important to to seek out those opportunities and to present yourself as a capable member, like, hey, I'll be willing to take this task and perform it, finish it in time. And other thing, I think just advocating for yourself. If you feel like you're not being seen or heard, don't be afraid to speak up and advocate for yourself. That could include asking for more opportunities, feedback, or support. But sometimes we just need to bring the situation up front for the issue to be resolved. So I think those strategies have always helped me like overcome the situations. Thank you.
Thank you so much. Sarah, if you could respond next, please.
Hi, my name is Sarah. I'm a fourth-year undergraduate in the College of Arts and Sciences, where I study physics with a concentration in astrophysics, and I'll be starting my PhD in astronomy at the University of Cambridge next year. I have also certainly had the experience of not feeling like I was seen or welcomed as part of a academic scientific space. I've had times where I've tried to share ideas with people and been brushed off, and certainly had the thought, would they have brushed me off like that if I wasn't a woman, if I wasn't, presenting the way I do? And unfortunately, it happens the most, I think, in spaces where you are not already known to the people you're speaking to. I've had, fortunately, great experiences here at Penn where the professors I've worked with, the postdocs, the grad students have always seemed very happy to hear what I had to say, been very welcoming. But in spaces where, you might be a newcomer, where you don't know people quite as well, I think it is easy to feel brushed off or forgotten. And I have a favorite phrase that I've started to use when I think about this. I think about like digging my heels in and being a little bit stubborn about it. As was mentioned, I think speaking up, refusing to be silenced, even when people don't seem to want to listen, is valuable. But I think also there's value in physically being seen. I personally find it like very empowering to be very feminine presenting. I like to wear dresses. I like to do my makeup and things like that. I find that empowering, especially in a space like physics that is very male dominated. I think there's power in standing out in some way like that. I am also blind. When I walk around, I have a guide dog. I am aware of the fact that I stand out for that reason too. I think there is value in, as I said, digging your heels in and refusing to be any different from who you are, even if that looks different from how everyone else in the space is. That definitely makes me feel seen, knowing that I am myself, that I literally physically look like myself, and that I am still going to be a part of the physics community.
Thank you so much for sharing. And next, Olivia, please.
Hi, everyone. I'm a second-year master's student in mechanical engineering. My background is in biomedical engineering from Drexel University. While I was there, I did co-ops in medical device product development at Globus Medical and Diffuse Syntheses. And at Penn, I'm a member of Advancing Women in Engineering and Penn Graduate Women in Science. So to answer the question, yes, I've had these situations where I felt not seen. Specifically in my co-ops, I've been on teams where we bring in surgeons and then we have our own engineering team. And these are design meetings where we're passing around ideas. And in a lot of these situations, I am the only female, and also I'm being outranked by everyone. Like, everyone has been there longer. In some senses, they know more than I do. So in these situations, the best thing that I can recommend is to ask questions, because there's always more to learn. And as you're gaining this knowledge, you become more powerful asset in the conversation and then also in the progression of the project. So you can become an active player moving forward. If you don't feel that way at that point, you can gain that knowledge and you can participate even more going forward.
Thank you. And Ashwathi, please.
Hi, my name is Ishvati. I'm a second-year PhD student here in Penn, specifically in the cancer biology program. And definitely when it comes to not feeling seen or taking up space or struggling to, that's definitely something that I feel like everyone here has experienced, and that's the same for me as well. And so for me, when it comes to taking up space, I generally see that as asking for the attention and support that you're entitled to as a student, as a member, as a part of a team. So by asking questions, you shouldn't feel like you're inconveniencing anyone or intruding on their time, because I know that we can tend to be a little considerate, perhaps a little over considerate, and feel like, oh, maybe they're too busy, maybe they just don't have time for me. But you need to realize that you're entitled to that attention and support. And so there's nothing wrong in asking for that kind of support. Also, when it comes to being seen, I know that it's been mentioned before that it's really important to advocate for yourself. And I think that's also another area where I've personally been super shy about asking about different opportunities, grants, mentorships. But it's really important to realize that no one else is going to do that work for you. And especially as a woman, you need to be a little bit more on top of that when it comes to outright asking what opportunities are available for me and seeking those out and applying to them.
Thank you so much. This next question is going to be for Olivia and Nebiat. Do you ever feel like an imposter? And if so, how do you face it and overcome it? If you have not, how would you help others to address it? Olivia, if you want to go first.
Sure. So I talked about how in my undergrad I did biomedical engineering and now I do mechanical engineering. So doing that switch was a bit tricky because I'm coming into the master's space where people that are a higher level of school, but then also they have this background in mechanical engineering that I don't, and something that I want to have and I want to learn more about, but it's definitely intimidating. So for me, I used it as a motivation to work harder, where if we were learning about a topic in class and it seemed like everyone had heard this before, but I hadn't, then I took that extra time after class to look it up and become an expert in it in my own sense, figure out what they're talking about, and then how I could learn more about it and use it going forward. And also, it's very important to accept that I'm not going to know everything, but also acknowledge that I have my own strengths and experiences that I can bring to the table that set me apart from everyone else and make me a valuable person as well.
Thank you so much. And Nebiat?
Yeah, for me as well, coming up from an all girls high school where everything was done by women. And I grew up super empowered. Coming to Penn was a kind of a transition for me. And I've definitely found myself feeling an imposter syndrome in some situations. And one thing that really, really helped me was talking with others and sharing this feeling. You would be surprised by how many people have the same thoughts and share the same feelings that you are going through in various aspects. So particularly sharing this experience with people with similar academic interests, backgrounds, and goals really helps to create the safe space to support each other, and especially as a woman in STEM. Another thing I do is challenging my negative self-talk by celebrating my accomplishments, like reminding myself of all of my strengths, all the things I've worked through to get to where I am right now. Every time I'm having this negative self-talk, I just challenge that with my accomplishments and my strengths. Besides that, I think appreciating learning and figuring things out in general is super important. We've all been in situations where we thought we wouldn't be able to pass through with flying colors, but looking back, we're always like, wow, that was a great learning curve. And sometimes it's really hard to understand and see that while we are in those situations that make us feel like an imposter or something. But looking back, we've always learned and grown from them. So I think just understanding that while in this situation is really helpful to overcome this negative thoughts.
I completely agree. My next question is going to be for Sarah and Ishvathi. Do you have a female mentor in your life? And if so, how did you find one? If you have a mentor who is not female, how did you find them? If Sarah could start, please.
I've been very fortunate to have a variety of amazing mentors who I really think I wouldn't be doing anything of what I'm doing without them, both male and female mentors. My thesis advisor currently is Robin Sanderson in the Department of Physics and Astronomy. She's wonderful. I think finding mentors through research, if you're interested in scientific research, is an excellent way to find a support system. My other mentors who aren't women are also my former research mentors. Booth Jane and Keith Hawkins at UT Austin have both been incredibly supportive, and I found them the same way just by doing research for them. And they've always been so encouraging of my career. Also, Anne Vernon Gray at the Center for Undergraduate Research and Fellowships is wonderful and has supported me so much. And so she's a mentor who I found a different way. Yes, still through research, but I've never done research for her, as my supervisor. So you can find these mentors through CURF, through the Center for Undergraduate Research and Fellowships. They can connect you to people. And if you want to find these direct research supervisors for mentorship, CURF can also point you in the right direction. In particular, the Research Peer Advisor Program will partner you with an older student in your field who will know your department and can point you at professors who are known to be good mentors, including female professors, if that's who you're interested in working with. So there are resources on campus to connect you to these mentors who will support your academic journey. It doesn't have to be just luck of the draw, hoping you get good research mentors. There are tools in place for you.
Thank you so much. And Ashwathi.
Yeah, so definitely, like Sarah mentioned, I feel like the most natural way to come across a mentor is definitely looking at teachers that you've already interacted with in classes, or specifically in my case, as part of the PhD program here at Penn during the first year, they have you do different rotations in a couple different labs just to get a feel of the vibe. And so 2 of the 3 of the people that I rotated with were female faculty members, and currently are some of my trusted mentor and faculty advice givers, and are helping me extraordinarily during this prelim process, which is a stressful time. But I feel like using that natural connection that you have during those rotations, during classes, you already kind of know them, they know who you are, but then taking it from there, you really need to put in the effort to maintain that relationship, because of course, these faculty are extremely busy and they're trying to spread their time really thin. So taking it upon yourself to reach out to them, schedule meetings with them, because they're super excited to hear about what you're doing and how they can help and how they can provide you input. But sometimes it gets lost in the sauce of everything that they're doing. So just being like really forthcoming about that helps a lot. And as for non-female mentors, I feel like my PI from when I was in industry and the PI I have now, Dr. Louis Chodos, are both excellent mentors and have an extensive career in being able to produce scientists that are both female and male and tailored to the challenges of both of those things. So even with the PI that I had from industry, it's the same thing with the other PIs, where you have to kind of put in that effort to maintain that relationship. And it's always super important to get an external perspective on whatever you're doing. So it's definitely a strength to have people that aren't directly in your field, directly in your little area of research. So definitely try to diversify a little bit when you're looking to, I would say.
Definitely. Thank you so much. And this final question, or pre-prepared question, then we'll go to questions from the chat, is how do you all find relief from the stress of your studies? And how do you maintain your center? First, if Nebiat could answer, please.
Yeah, I think just to relieve stress from my studies, I just tend to do things that actually make me happy besides academics. I love cooking. I'm a huge fan of Ethiopian cuisine, so I'm always cooking when I have free time. I love spending time with my friends and families. I tend to do that a lot, play tennis with my friends, and also exploring the Philadelphia city and also the food scenes around there. So basically what I would say is like making sure that I'm doing what actually makes me happy besides academics, but at the same time, taking that break, making sure that it's an actual break. I tend to separate work and school and my breaks. So I do everything that I need to before or after, so I can actually enjoy what I'm taking, those breaks, to help me relieve stress from my studies.
Definitely. Sarah, if you could go next, please.
I sometimes say half jokingly that the reason I study astrophysics is because of Star Trek. I grew up watching Star Trek, but also only half jokingly, it keeps me in astrophysics too. At any given moment, there is a non-zero chance you'll find me in the astro wing of DRL, not doing work, but watching Star Trek, both because it's fun, but also because I find it inspiring. It reminds me of that sense of awe that originally drew me to physics. So it's sort of a double win, stress relief, not work, but also reminds me of why I love what I do. But I also do things that aren't strictly space related. Nothing more fun than playing with my guide dog when she's not working, spending time with friends, all of those fun things. I also love to read. I could definitely spend 8 hours just shut alone in my room with a good fantasy novel. I think there's real value in I suppose these sorts of escapes from, the stresses and the to-do lists of daily life. But these escapes can also sort of foster that sense of wonder and curiosity that you have.
Definitely. Thank you. And next, Olivia, please.
So similar to what Nebia and Sarah have said, boundaries are so important for me. Really setting off a cutoff for the end of the day. So I try really hard to keep that schedule of 9 to 5, even though it's not a job, it feels like a job. So I try really hard to get my work done early so that I can wrap it all up by 5 or 6. And some days it doesn't work out like that. Sometimes I might have a group project or I need to study and I need to be available after that. But if I can keep that to, once a week or once every 2 weeks, then that's a lot more feasible for me. So if I can maintain it between that block of 9 to 5, then I can actually shut it down and enjoy myself after that, which is really, really important to be proficient and productive the next day. You need to be able to have that break the day before. So I like to be able to cut it off at 6, and then in that time I'll just do something with totally relaxing, watching TV, turning off my brain, listening to music, getting outside, going for a walk, just something where I don't have to think a lot and I can just rest so that I'm ready for the next day.
So important. And Ashvathi, please.
Yeah, I think for me, one of the major things I do, which might sound a little radical, is I celebrate everything, every little win, whether it's turning in an assignment that was really stressful for no reason, a stressful meeting, a presentation. I will treat myself 100%. If it's like a little meal from Grubhub or a walk to go get some boba, I'm specifically like, okay, I got through this thing that I was worried about. Regardless of the outcome, I'm celebrating that I did it. And I feel like that always puts a pep in my step. And then I was talking to actually a lab mate of mine named Sarah, who gave me this really great advice that I wanted to share. And she mentioned that in science, usually, especially in research, there's a great degree of flexibility. So you can plan your research and experiments kind of the way that it makes the most sense for you. And so the way that she does it is she plans fun things first. And so she plans trying out different restaurants, rock climbing, hanging out with friends first, and then has science kind of fit around it. And I think that that's so important to treat the fun stuff as not the afterthought all the time. And remember that you can kind of make it work for you too. And so that's definitely something that I'm going to be incorporating in my future scheduling for sure.
Thank you all for sharing. One question that we have from the chat, which any of you can take, and also I invite all of our viewers to continue to ask questions if we have time to get to them for this panel. But in a situation where you faced bias or discrimination, did anyone intervene? What did they do, or what did you wish they had done if they didn't intervene? Anyone, open for anyone.
I think I've been fortunate that as I've gotten further in my academic career, so to speak, it's happened less and less. But certainly, especially when I was younger, people would say things about the fact that I am a blind woman who wants to do physics. I remember once I had a high school classmate who told me I only did so well on our physics exams because of my accommodations that I get for my disability. And no one did say anything. In fact, I think maybe a lot of people agreed with him. I think in those cases, it's always nice. It's always you always hope that people will step in and say something like, hey, that's not how that works. People might say, you only got that position because you're a woman, you're only here because of that. And you always want someone to say, hey, don't say that. That's not how it works, but they won't always say it. So, either you can be the one to say that, point out your successes, which I also unfortunately didn't do when this person said that to me, but also just try to remember that what they say can't take away what you have succeeded at. No matter what they think of you, it doesn't take away from the fact that you have actually succeeded, and I think going back to that phrase I used earlier, that idea of being stubborn and digging your heels in, I think to some extent, the more I knew that people were expecting me to fail because of my vision, because I'm a woman, the more I wanted to succeed. I think I have a really stubborn streak in me. So I definitely turned those doubts and that discrimination into a passion to keep doing well, to prove them wrong.
Thank you so much for sharing. Does anybody else have anything they would like to add, or we can ask another question?
That was a really good answer. Let's ask another question.
Actually, I don't think we have time for any more questions, but I would like to thank all of you, Neviat, Sarah, Olivia, and Ishvathi, for engaging us in a brilliant conversation this afternoon. If you could give them a round of applause in the chat. Next, we are going to be hearing some brief remarks from Dr. Erika James, the Dean of the Wharton School.
Good afternoon. I'm Erika James, Dean of the Wharton School. It is my distinct honor to be asked to join this event today. Before we go any further, let's give the event organizers and all of today's participants an appreciative round of virtual applause. I am so inspired by the Student Planning Committee, which has dedicated its time to bringing leaders in industry and the Academy together for this symposium. And I'm energized by this event's overwhelming popularity. As the world's first and most formidable business school, Wharton is focused on preparing the business leaders of tomorrow. Through our world-class, evidence-based curriculum, we equip our students with the necessary skills and knowledge to lead in a world undergoing tremendous change. Our mission for a brighter business future is supported in no small part by analytics at Wharton. It is one of our core research pillars. Wharton is invested in our students' access to analytics and data science, as these fields have transformed our world and industries and created myriad new business opportunities. We've made several strategic investments in this arena in recent years. I'm particularly proud of the extraordinary growth of our business analytics concentration and major, which was introduced less than 5 years ago, and in that short time has become one of the most popular areas of study among our students. Our faculty are spearheading trailblazing research to uncover new insights into everything from eliminating bias in hiring to better understanding the impact of stress on health outcomes. And our students are putting their classroom learnings to the test through analytics accelerator programs, datathons, and competitions. Wharton is also aligned with Penn in the belief that women play a pivotal role in the world of STEM, and that data science and analytics should be foundational areas of study in STEM-focused learning and initiatives. Wharton's very own Women in Data Science initiative explores the extensive diversity of data science in terms of both real-world impact and leadership in the field. We support STEM-focused learning in Wharton's global youth programs because we recognize that these subjects are paramount to the preparation for higher education. Similarly, in our degree programs, Wharton offers STEM certified majors and specialties, and these skills are vital to our students' success in the business world post-graduation. I'm equally proud of the commitments Wharton has made to push for further representation in this field and in business education more broadly, from faculty and staff to current students, and to featuring alumni role models in student-facing programming opportunities. As a female leader and someone who has studied women in leadership positions, I know firsthand the significant impact that gender representation can have on women as they chart their careers. I hope you will not only be inspired by the phenomenal women, peers, and conversations you will have today, but that you will uncover new pathways to explore during your time here at Penn and in your career.
Thank you to Dean James. And next, the upcoming Assembly on Research is going to be presented by Jensley Soto Albrecht and Aditi Singh. This panel will look to highlight the diverse and impactful work that women researchers are conducting at the University of Pennsylvania. Jensley, if you're going to be going first, please.
Thank you so much. Allow me a moment to share my screen. Can you see my slides all right?
Yes.
Wonderful. Thank you. My name is Gently, like the adverb. I'm a fifth year MD PhD student here at the University of Pennsylvania. And today I'm going to talk to you about how mitochondrial oxidative phosphorylation, or OXPHOS, serves to regulate how much SARS-CoV-2 virus is made by cells. As you all probably know, SARS-CoV-2 causes COVID-19, the ongoing pandemic. As a coronavirus, it replicates in the endoplasmic reticulum in these structures called viral organelles, or double membrane vesicles. And inside of these structures, you can find double-stranded RNA, which marks the site of viral replication. Now, we know from other people's work that SARS-CoV-2 actually downregulates mitochondrial OXPHOS during infection in infected cells, human tissues, and animal models. Yet whether or not mitochondrial OXPHOS is required for SARS-CoV-2 replication is not known. In order to understand this project, you need to know a little bit more about mitochondria. So they have their own DNA, which expresses a subset of their own translation machinery, and in turn expresses 13 peptides, all of which contribute to the electron transport chain. So I decided to shut down this pathway using 3 different approaches shown here. If you can get rid of the blueprint or the mitochondrial DNA, no OXPHOS is able to be made. Or if you inhibit mitochondrial translation, you shut down OXPHOS. And lastly, you can inhibit OXPHOS directly by using drugs that target the electron transport chain. And while I won't have time to show you any validation data today, I will show you these electron microscopy figures that demonstrate that these approaches actually change the structure of mitochondria. So these are A549 ACE2 cells, human pulmonary epithelial cells, and wild-type mitochondria have these lines, which are cristae. And if you treat cells with an inhibitor of mitochondrial translation, CAP, you lose these cristae. And if you remove mitochondrial DNA in these row 0 cells, you also lose these cristae. And this shows you that these approaches are able to shut down oxidative phosphorylation. So I made these different models, and then I infected them with SARS-CoV-2. And on the y-axis are plaque-forming units, or infectious viral particles. And this is log transformed. So a 3 means 1,000 viral particles, and 6 means 1,000,000. And this curve shows you how much virus is being made by wild type cells. Now, when you inhibit oxidative phosphorylation, surprisingly, these cells not only make virus, but they make 10 to 100 times more virus. And this is recapitulated if you inhibit the electron transport chain directly using drugs. I wanted to see whether this phenotype was shared by 229E, a common cold coronavirus, which isn't as pathogenic in humans. And you can see that it is not. The viruses that make 100 times more SARS-CoV-2, or the cells that make 100 times more SARS-CoV-2, do not make 100 times more 229E. And this shows us that this phenotype is not pan-coronaviral. I've had a little time to explore this phenotype further. For example, I can tell you that when OXPHOS is inhibited in these 2 conditions, cells release virus 2 hours earlier than wild type cells. They release virus at 6 hours post-infection, wild type cells at 8 hours post-infection. I've also looked at where the virus is replicating in these infected cells. And here in the red channel, every dot is a viral replication center. And here, every dot is a cell. And so you can see that the amount of viral replication centers is higher in the conditions where OXPHOS is inhibited compared to wild type. And these viral replication centers are also more widely distributed in the cell when OXPHOS is inhibited, both seen by the area of viral replication as well as the distance of these replication centers to the nuclear edge. In order to further lend evidence to this story, I put mitochondrial DNA back into cells to turn OXPHOS back on. And my hypothesis was that this would reverse the phenotype. And in fact, I found that turning OXPHOS back on actually was able to decrease the amount of virus that these cells made and delay the kinetics of viral release, as well as revert all three of these phenotypes. So now these cells make less viral replication centers. In these replication centers are less distributed. So to summarize, I've shown you that mitochondrial OXPHOS regulates SARS-CoV-2 replication. I first showed you that by cells lacking OXPHOS at the level of mitochondrial DNA or mitochondrial translation made 10 to 100 times more virus. And when I put mitochondrial DNA back into cells and turned OXPHOS on, I showed you that this limited viral replication and the distribution of our replication centers, as well as the kinetics of virus release. I want to take a moment to thank my lab and my mentor, Doug Wallace, to thank the collaborators in Boston in the Duom lab, where I did a lot of these experiments, and my collaborators here in the Weiss lab. And I'm happy to answer questions later, not just about this project, but also about American Physician Scientists Association, which is an organization for physician scientist trainees that I'm president of. Thank you so much.
Gently, thank you so much. If you have any questions for her, please put them in the Q&A to be answered after Aditi's presentation. And Aditi, whenever you're ready.
Just waiting for my slides to be shared. One moment. Amazing. Okay, so my research study, I've been working on this for the past 3.5 years, is basically about the sex differences in the way that opioid withdrawal presents in men and women. Next slide, please. So I've been working at the Danny Lab for the past 3.5 years researching this, but we all know that the opioid epidemic is a huge issue right now because opioids are, in fact, the best pain meds that we have in the market, and they are the most effective. But unfortunately, they do have an extremely rewarding effect and are very easy to get addicted to. In fact, they have a 70% relapse rate for people who have been before addicted to opioids and then able to quit, but then have go back into it because it is so difficult due to the acute withdrawal symptoms when you have left this drug. So what my research study particularly focuses on is what this withdrawal looks like and how it is different for males and females, because a lot of the studies in this field have been focused on males and not really understanding how female withdrawal looks from opioids. And so drug therapies are mostly targeting what we know about male withdrawal as opposed to female withdrawal. And my hope is that my research will be a small dent in that and trying to change that for the future and the field. The differences that are seen in humans, which show us that males and females are in fact different in the way that they react to opioids, is how females actually report a lot more craving for opioids, and they also tend to experience a lot more distress compared to men. Next slide, please. So I worked with my lab mentor, Dan and my PI, Dr. John Danny, on understanding and finding goals for this study. So particularly what we're looking for is, one, trying to find a non-opioid therapy to treat opioid use disorder. Today, the current therapies for opioid use disorder are opioids. They are just not as rewarding, but it would be easier and require much less regulation if there was a non-opioid therapy. Secondly, we're trying to find drugs that would target these underlying mechanisms of withdrawal and finding that brain pathway that is responsible for the withdrawal that is caused by opioids to sort of reduce that negative feeling and all of the negative symptoms that are associated when you are being treated for opioid withdrawal and experiencing chronic pain as well. And lastly, we are hoping to understand what that pathway is and find drugs and therapies, for example, two of which I will talk about today, LNAME and CLP, which would hopefully reduce the anxiety, stress, and depression that is associated with opioids, which would reduce the relapse rate for people who might be addicted prior and have been able to leave it. Next slide, please. Okay, so the methods of the study, what we do in the lab is there are mice in cages and we inject them with morphine injections twice daily for 5 days in order to make sure that they are sort of representing humans that might be addicted to opioids and have had double doses of opioids every single day. Then on the 6th day, we stop the morphine injections and just observe the mice in cages to see what symptoms they are exhibiting, which are alike to withdrawal. For example, shaking, and they have jumps, and sometimes they walk backwards, and all of these symptoms that are associated with opioid withdrawal. 1 week later, we have tests called the tail suspension test and the splash test, in which we are looking for mice exhibiting depression-like or anxiety-like behavior. For example, in the tail suspension test, if the mouse tends to give up faster than controls when they are when they're experiencing opioid withdrawal, or in the splash test, especially female mice in this case, tend to exhibit less self-care or less grooming as opposed to control mice. Now, the study that I was working on currently for my thesis looked at this drug called LNAME that we gave the mice in their drinking water. So we were trying to see, for the mice that were experiencing opioid withdrawal, if we did give them this drug, what would happen? And in fact, when we did give them LNAME, all these behaviors that they were exhibiting that were associated with opioid withdrawal actually reduced, and they went back to what the baseline somebody who wouldn't be experiencing withdrawal would look like, and there wasn't a significant difference. Next slide, please. So what we are hoping and what the conclusions of the study are, firstly, that LNAME actually targets this brain pathway called the nitric oxide synthase pathway. And this might be where one of the targets for opioid withdrawal drugs that would reduce that withdrawal, that would reduce people relapsing, because if we inhibit this pathway, we might be able to inhibit the negative effects. And then another key aspect of my study was just to try to understand the difference between males and females, to have better drug therapies that might actually specifically target the differences between men and women. Thank you so much. And finally, I would just like to acknowledge my lab and my mentor, Daniel Calamarides, for helping me out with this study. Thank you.
Thank you so much, Aditi. Now we're going to move on to some Q&A for both Gently and Aditi. Please continue to put questions in the Q&A box for them. But the first question that I have is for Gently. Could you give us a little bit more information about your path to a STEM career and yeah, just a little bit more about your background?
Absolutely. So I come from a middle-class background, and I somehow got into Princeton for undergrad. And I say that because it was a complete surprise to me. And so while I was there, I really found myself loving molecular biology, but feeling very hesitant with the concept of applying to medical school. About halfway through undergrad, I learned what an MD PhD was, and I realized that it was kind of a gateway to more translational research where you'd be able to have access to patient samples and maybe ask more questions that were kind of closely related to your ability to apply them to patients. And I realized that I'd have to apply to med school if I wanted to do that. So I just kind of it took me about a year to kind of feel comfortable with like taking the MCAT, which is very competitive. I realized I needed to take a couple gap years because I really didn't have the time or the emotional bandwidth to like shadow in a hospital or volunteer in a clinical setting before doing that. So I took 2 gap years, and during that time I shadowed some physician scientists and I took the MCAT, and I applied to MD PhD programs thinking I wasn't going to get in, but it ended up having a very successful cycle. So I just really highlighted all the times when I was really insecure about myself, because I think that that's probably a common thread with a lot of women, just like feeling like we maybe don't belong in this space. We're not seeing a lot of people who look like us, especially, you know, like Latina women in the field. But like, just like trust yourself, and also just like figure out what steps you need to get where you're going. And if you're able to find mentors in the field, they can really be a great source of support and telling you that you can do it even when you don't feel like you can. I hope that was helpful.
As someone who wants to go into research, yes, very helpful. Thank you. And Aditi, a question for you is, what do you think is next for you in terms of your research?
So I'm currently completing my honors thesis at Penn in neuroscience. So that's really what's next. I'm going to be presenting at a symposium. I think that when I move forward, I'm not really sure how much I'm going to be continuing in this specific research once I graduate, but I'm definitely here for another year and I really want to do as much as I can. And then I want to move on to medical school. And then hopefully also just investing myself in trying to help people with opioid addiction and withdrawal is something that I'm very passionate about, because now that I understand it so much more, I think that I want to actually work in that field outside of this.
Thank you so much for sharing. Thank you to both Aditi and Gently for sharing some brilliant slices from their research. Next, we are going to have our final assembly. Doctors Nadia Crook, Ariel Keller, and Corlette Wood will present the last assembly on career progression. Career progression is key to achieving a more gender-balanced STEM workforce. In this panel, themes center on the likeliness of wanting to work for an organization, if there are clear and transparent role models in senior positions, and the value that organizations place on making people feel like they belong in the workplaces. So I'd like to now welcome our panelists. Similar to our first assembly, I'm going to ask you all to please introduce yourselves and then to answer this first question. What originally inspired you to get into STEM and how did it shape your career? If Dr. Crook could go first, please.
Good afternoon, everyone. My name is Nadia Crook. I am located in California, so my morning, but good afternoon to you. So I was born and raised in Kalamazoo, Michigan. I went to Lehigh University for undergraduate. I majored in material science and engineering, and then my connection to Penn is I continued with my graduate studies at the University of Pennsylvania to get my PhD in the Material Science and Engineering Department under the advisement of Dr. Russ Composto and Dr. Chris Murray. I graduated in 2019 and I'm now a lead engineer at DuPont based out of California doing project management for new product development. And then kind of my inspiration into STEM, I grew up in the privilege of a family of scientists. And so I have an older sister and a mom who are both chemists. And so seeing them succeed and lead in the area of STEM with confidence made me feel like I did have a place in the room. I did have a voice to be heard. And I had a lot of inspiration from women who stepped in front of me that I could step behind.
Thank you so much. And Dr. Keller, if you could go next, please.
Sure. So I'm a postdoctoral fellow in psychiatry at Penn, and I'm originally from Massachusetts. My research is really interdisciplinary. So at the intersection of psychiatry, human neuroscience, developmental psych, and cognitive science, with the broad goal to try to understand cognitive impairments in psychiatric illness. I earned my bachelor's and master's degrees in neuroscience from Brandeis in 2016, where I was investigating behavioral signatures of multisensory attention. And then I earned my PhD in neuroscience from Stanford in 2021, where my dissertation was focused on characterizing attention impairments in depression and anxiety and their neuroimaging signatures. In my current research as a postdoctoral fellow, I'm investigating how different kinds of environments and experiences during childhood shape functional brain network development and cognitive abilities in kids. Oh, and did you want me to answer what originally inspired you to get STEM?
What inspired?
Yeah, so my story is kind of odd in that I never thought of myself as a science person ever. I went into college thinking I would be an English major, and I loved psychology. I loved trying to understand how people think. But I took a class called Intro Cognitive Neuroscience, and that just totally changed my career trajectory. Where I suddenly realized that there was this systematic and scientific way to understand the neurobiology of how we think. And that was just so beyond cool to me. So I went to the professor at the end of class, was like, I really want to join your lab. I would love to learn to do research. And he was like, absolutely not. You have no skills yet. Like I was brand new. I was a freshman and I was an English major. And he was like, I don't know if you have the skills to do this yet. So I asked about, well, what do I need to know? And it was kind of this process that took months where every day after class, I would come up to him and say like, can I join your lab now? Can I join your lab now? And I would go and learn. He would be like, well, you should learn how to code. And I would come back with this coding thing. And it was a back and forth, but the main takeaway is that persistence is key. And I just had the best time working with him. He was an incredible mentor in the lab. And just being able to picture yourself as a scientist, I think is the first step towards like building that self-confidence.
Thank you so much for sharing. And Dr. Wood.
My name is Corlette. I'm an assistant professor of biology here at Penn. My lab works on plants and microbes. We do a combination of field-based work. So I spend my summers living in a cabin in the woods, as well as lab-based work right here in Philadelphia. I did major in English literature. So I got my BA in English in 2008 from Swarthmore College, so just outside of Philly. And then my PhD in biology in 2015 from the University of Virginia. So for me, actually, much like Dr. Keller, I didn't originally think of myself as a scientist or as a STEM person. I love language. I love thinking analytically about how language works. I love writing. And it honestly never occurred to me to be a scientist. I loved learning about biology. I loved learning about physics. I love math. But for some reason, it never occurred to me that was what I should think about for a career until I was a junior in college and was thinking about what would come after college. And what I realized at the time was that there were three aspects. So I'd had a couple of research assistant jobs at the time. One of them was working as a field tech locally in the Philadelphia area. The following summer, I worked as a field technician down in the Appalachian Mountains. And those experiences helped me see that there were three things I wanted my work life to have. One of them was working with my hands, which is something I get to do in science all the time. Another was working with math and working quantitatively. I love quantitative concepts. One of the classes I teach now is statistics, and it's one of my favorite things in the world. And then the third thing was working with other people. And something that is really amazing about being a scientist is that I lead a lab. I get to work with a team all the time. And so for me, it was sort of a confluence between what I actually wanted my day-to-day work life to look like, as well as the concepts that I really loved learning about. And for me, that's biology, specifically ecology and evolution. So that's sort of where I got to where I am today.
Great, thank you so much. Next question is for Dr. Crook and Dr. Wood. What was the biggest challenge or adversity that you ever faced working in STEM, and how did you overcome it? Dr. Crook, if you could go first, please.
Yeah, thank you, Harper. So I think this is still one I'm working on, and it's really belief in myself. And I think this is a common thread across a lot of people in the room today. And so it is still something I'm working on, right? I am 3 years into my career in industrial chemistry now. There's challenges that come up every day that are new to me, and I'm really uncertain kind of sifting through that and, how do I approach new problems? and really having the confidence to bring my whole me to work every day, and whatever that is. So as I said, I'm still working on it, but what has helped me tremendously, and I think is a common thread in the conversations today, is really finding mentors and people who can kind of turn a different mirror that reflects back on me, saying, you know, you might not have the confidence, but here are attributes that you have, here are strengths that you have in solving this problem. You know, something that I really love doing at work is bringing teams together with different perspectives. We have global teams, multifaceted teams at DuPont that I am tasked to lead. And so bringing people with different perspectives and seeing them as people coming to the table with a different perspective an approach to solving a problem. And so bringing that strength of, one of my strengths is bringing people together, harmonizing a team, allows me to kind of work through this and also find these mentors and sponsors of my career that believe in me and will continue to bring opportunities to me, be kind of a cheerleader through my career. So again, still something I'm working on, but I think is belief in self and confidence, and bringing mentors every day, finding people to talk to kind of work through that has really helped me.
All right, thank you for sharing. And Dr. Wood?
Yeah, what Dr. Crook just said really resonates with me as well. And I think something that I'd like to add to that is that for me, something that can be challenging about working in STEM is that sometimes self-doubt comes from external sources around me. So some of those, for me, are experiments failing. If any of you have had research experience yet, you'll know that that's a universal experience. Science never works the first time. For me, it usually doesn't work until the 10th time. And so there's a lot of times that things go wrong. And so with all of that, I think it can, like, having a really strong sense of self and a strong support network can be really, really important. And having other people to talk to who are also going through the same things. So you understand that it doesn't reflect on your abilities at all. It's just the way that science works that you never see when you see the polished, finished product. And I think recognizing that and not letting it get you down was one of the most important things that I learned in my PhD. I think it's a lesson I'm still learning a little bit every time an experiment fails. But it gets easier every time because I know that it's normal and it doesn't reflect on me or my skills or abilities.
Absolutely. Thank you so much. And this next question is going to be for Dr. Keller and Dr. Crook. How do you manage working in an environment where you are among the few women? Dr. Keller, you can start, please.
Sure. Yeah. So I think a lot of what's already been said, like finding great mentors is a huge part of that, and learning to trust yourself. I also find that, like, outside of science, my friends and the people who I interact with through other interests are there to give me a lot of support as well. And that can really help. We mentioned imposter syndrome and how helpful it is to hear other people talk about it. So that's definitely something that I experience, and that I find the best way to get past imposter syndrome is to talk with other people about it and realize that it's not just me. And then I also wanted to build off of something that Dr. Wood mentioned, which is that it's hard to compare your insides to everybody else's outsides. Very often we have this kind of duck phenomenon, which is like, if you picture a duck just like floating along the surface of the water, it looks very calm and smooth and it's totally got everything together, but underneath the feet are paddling like crazy. And I think it's just helpful to remember that we are all, like, if we only look at the finished products, like the final polished science, that it looks like everybody else is succeeding way more than we are, when really science is messy and it's challenging. And so being able to persist through that, I think is really important.
Definitely. Thank you so much. And Dr. Crook?
Yeah, I also really resonate with what Dr. Keller says that there. I think that it's oftentimes we see, other projects and we see, other research maybe going on. And as Dr. Wood said, you see the final project. So you don't see that kind of quick paddling of the duck underwater that took to get to that final product. So we did talk about mentorship, but similar to what Dr. Keller said, I said, finding peers. I had a really good fortune when starting my career that 6 of us hired in at the same time. And I think we all came with a lot of uncertainty, and we really kind of disarmed ourselves of putting up that barrier of proving to each other we all belonged in the room. Is we actually were really honest with each other and said, we're all going through a big career change, going from our academic experience now to industrial chemistry. We all come from 6 different schools, 6 completely different backgrounds, and we really foster a good connection and community within the peer group. On a certain day, I might have had one of my friends, Rebecca, having challenges in her project, and I might have been able to connect her into my network. And so I think we started as a network of 6 people, and then we just kept opening each other up to, I just met someone here in another group, maybe they can help you, and opening your network to your own peers, finding people who have a common lived experience, talking about that, authentically sharing, I think does help to say you are not alone. Everyone is struggling. You might see, the duck really nicely paddling by, but kind of everyone's paddling their kind of quick pace on different things they're struggling with. So how can we help each other in this area?
Thank you so much for sharing. And the final question before we go to questions from the chat, and please feel free to continue to ask questions in the Q&A box, is what advice would you give to women entering into STEM work environments? And this is a question for all of you. If Dr. Wood could go first, please.
Yeah, so the thing that helped me the most was having a team of people who I knew had my back. And so identifying those people in your life, in any, whoever they could be, I think was really helpful. So for me, my parents and my brother are a huge support system ever since ever. They've always supported me and had my back. I was really lucky to have a great grad school cohort that really worked together and challenged each other in a super supportive way. And I should say that many of them were men. A lot of my buddies then and now have been men who are really strong feminists and were super supportive of me and advocates of me, which I think was especially helpful for rooms that I wasn't in. So I'll say that as well. And then the third thing that has been really helpful for me is identifying role models. So I'm in biology. It's still a male-dominated field, but certainly not only men. I'm rarely the only woman in the room. And I'm lucky to be a scientist in a time when I have a lot of senior women role models who have been super, super important to me, to help me navigate challenges that my male colleagues might not necessarily be experiencing. And so ever since undergrad, I've had sort of this tiered support system of people that are in science, that I have a professional relationship with, and people who are not in science, like my family, who are really supportive of me no matter what. And I think for me, that's been really huge.
Thank you so much. And next, Dr. Cook, please.
Yeah, similar to Dr. Wood, I think having that community that you build of people who will advocate for you, will continue to sponsor you, will continue to believe in you in the times that you might not necessarily believe in yourself. So I think that's that is something I would recommend, is really finding that community, finding not just one mentor, but mentors with different perspectives. Similar to Dr. Wood, I've had male and female mentors and sponsors. Also, becoming a mentor yourself, similar to what we are all going through. Know that there's someone who is looking up to you, looking to see what your career has looked like. So those people who are giving back to you, also as you get more comfortable, you have value in what you have to share too. So provide that back and become a mentor to those who are looking up to you, I think is really important. Also, take on roles that scare you the most. I think so. I'm saying I'm in California. I actually just moved my family across country in the last 4 months, taking on a totally new role, being in a new organization, probably a role that really scares me and intimidates me. But take on those roles that will scare you and challenge you to be a continuous learner, trying new things, pushing yourself beyond what you think you're capable of. When you have that community that backs you, that will continue to empower you in those challenges, it helps to kind of lessen that scariness. But be you, be brave, trust your instincts, and always let your voice be heard. So you are not alone. You belong in this room, just like the 4 of us here right now. People like us are all a short email, LinkedIn message, and phone call away, and we're all eager to help and want you to succeed. So we can be mentors to you if you ever have questions. We're all here to help each other.
Thank you so much. And Dr. Keller?
Yeah, so I completely agree with the things that have already been said. Things I'll add to that are, first, that science is so much fun. Like, if you feel like you might want to do it, it's not too late. You don't have to compare yourself to what other people have already done, and don't be afraid to seek it out, even if people tell you that if people try to put barriers in your way, like, don't let that stop you. The other thing I'll say is that science is really all about learning and not about knowing things. And I think that often gets misconstrued. And so my advice for people who are interested in going into research in particular is to really, and this kind of applies broadly, but to really celebrate your own personal growth and the learning process rather than the outcomes, like the achievements and milestones and an experiment working well, because those oftentimes in science can be few and far between, and the personal growth and the learning that happens in between them is really where all of the power and strength comes from. And last, we'll totally echo the thing that we keep saying over and over, which is find great mentors. And I'll say that finding great mentors is more important than finding a perfect scientific project, because oftentimes projects will change, research labs can change. You can get excited about lots of different kinds of things, even beyond what you think you're going to want to study. When I first entered grad school, I thought I was going to study something completely different from what I ended up actually studying. And the most important thing was just having someone as a supportive mentor who would always have my back no matter what. So I'll leave it with that.
Thank you so much. Now to answer some of the questions from our Q&A, the first one I'm going to direct towards Dr. Wood. What advice would you share with students who are majoring in humanities and want to pursue pure sciences and math?
Yeah, so it's a great question. I can certainly tell you how I got there and offer some maybe general ideas of how to navigate that transition. So first, I should say that while I was an English major, I also had been taking STEM classes. So I had some background in the field that I was switching into, even though it wasn't my primary focus. The other thing I should say was that I was really lucky to be at a school that I think is structured kind of like Penn, that values the liberal arts, so values a broad education, and made it somewhat easy for students to explore interests in other departments. And so I took advantage of that by approaching faculty in the biology department at my college and asking about paid opportunities to get experience. I was a work study student, and so that was how my first research experiences came about, was paid lab opportunities. And you can look into those through Penn, through places like CURF. So there's a bunch of different boards, like job boards, that you can use to search for those opportunities. Labs like mine advertise those positions every semester. And I can't speak for all labs, but my lab requires very little experience, like prior experience. In fact, we don't expect any prior lab experience for folks working in our lab. What we do expect is a genuine curiosity and interest in the stuff that we're doing. And so I think that speaks to what Dr. Keller and Dr. Crook were saying about sort of a growth mindset. We definitely don't expect that you know everything, but we expect that you are excited to learn things and that you believe that you can learn things. So I think that's one suggestion is to explore concrete opportunities to get experience. And the best way to do that is research experiences. The second thing that I would say is that in the long run, my humanities training has been a major asset to me as a scientist. My job right now is running a research lab. Parts of it I'm horribly prepared for. It's like running a small business. I do not have a business degree, but a lot of what I do is write papers and write grants. And those are things that my humanities training prepared me beautifully for. My science classes didn't teach me to do that. And so you should appreciate that you have a ton of skills you're bringing to the table that students who may have pure science training don't necessarily have, and that you might take for granted. So don't lose sight of that as well.
Thank you so much for the advice. And this is for anyone who wants to answer, but what advice would you have for girls and women interested in working in maybe not a traditional lab or clinical environment, but still in a STEM field? Anyone who wants to take it. Okay, or we can go to a different question if maybe this isn't the best place to speak on that one. I was wondering if you could give advice to your younger self in terms of progressing through your STEM studies, what would you say to her? Any of you could take this.
I guess I can jump in with this one. So I had an experience when I was a graduate student where I was trying a new kind of experiment in a totally different, with a very different perspective than what had previously been done in the field. And when I went to try to like communicate about that with publications or in a conference, I got a lot of pushback from some of the more like senior established scientists in the field, these like big name scientists who had kind of like a long-standing theory about how things worked. And there was pushback about this like new way of approaching the question. And at first I was so intimidated by that. I felt like, who am I to like jump into this new field? Like I'm an early stage trainee and I don't look like everybody else in the room. But if I could tell something to my younger self, the thing that really ended up helping was to think about writing and like communicating about my science from a place of curiosity, and also just learning to kind of like build self-confidence and persist, which comes from great mentorship too. But when I realized like the pushback was less about the quality of my science and more about the newness of the ideas, that motivated me to like keep trying. And my mentor at the time was like, let's just aim higher. Like if you're generating pushback, like that means you're doing something new and different, and that's valuable in science. So as advice for people on the call, I guess, like your perspective is valuable. And even if it's new and different from what has been done in the field for a long time, like trust that instinct, and it's really valued.
Yeah, and I, also building on that, not only are your perspectives valuable, but also your questions are valuable. So I think when I think back, especially in my college self, just I was pretty shy in asking questions. I think I always wanted to perfect it, or I would think to myself, you know, is that a silly question? Is that something that should be really kind of known in the art or really known in this discipline? Does everyone already know this? And I think I was pretty shy of raising my voice and actually asking the questions. And so I think I would give myself the advice of, you know, everyone's still learning. Everyone in the room doesn't know everything. You know, someone maybe knows a little bit about this area, and just be a little bit more, I think I would have said, be a little bit more fearless in asking questions and not spending time of rehearsing them in my head, making sure it comes out perfectly. And right, just ask questions too, because that might start a new conversation, a new dialogue, or even, you know, propose another way of thinking. And that is really valuable. So be a little bit more braver on asking questions.
Thank you. Dr. Wood, is there anything you would like to add before we wrap up the panel?
I would just want to echo both of what Dr. Keller and Dr. Cook just said, because I think it's really valuable, and it was almost verbatim what I was going to say, which I think says a lot that all three of us are experiencing some of the same things. The way I was going to phrase it is that I think I often assume that I know the least of anybody in the room. And it's really easy for me to see when I look back at my younger self. I'm sure I'm doing it now, but it's harder for me to see now. And I think just like Dr. Crook was saying, question that assumption. I'm not saying to be arrogant and assume that you know more than everyone in the room, because oftentimes that's not going to be the case either. But absolutely don't assume that you know the least. You almost certainly know more than everyone in the room about something, and a lot about most things. And regardless, your questions are always going to be valuable. I really loved how Dr. Crook and Dr. Keller put that. So that's all I'd add.
Thank you so much. And thank you to all of our fabulous panelists, Drs. Crook, Keller, and Wood. That is going to conclude our last assembly. I would just like to say thank you to all of our presenters, our sponsors, and planning teams. Let's please give one final round of appreciation to all using reactions in the chat. Once again, the recording will be available in about a week. Thank you so much, all of you, for joining us in the 2023 Women in STEM Symposium, and we will see you next year.